Now our topic is difference between SQL and NoSQL databases. We have already uploaded a course DBMS Module 1 in which we have already discussed in detail the common types of databases. Here we will concentrate on only two types of databases, SQL and NoSQL databases. Now the first difference on which we will be discussing is the data model. SQL databases primarily use relational data model. What is the relational data model? Relational data model is a model which makes use of tables to store data. In the table, there are rows and columns in which the data is stored. Now, in the case of NoSQL databases, they use various data models such as documents, key value, common family, graph, etc. Now the next point is schema. SQL databases have a predefined schema, which means that the structure of the database of the data in the database is fixed and well defined in advance. This makes it easy to query the data and ensure that the data is consistent. On the other hand, in the case of NoSQL databases, these databases are known for their flexibility and schema-less or schema-flexible approach. NoSQL databases are better suited for scenarios where data structures are less predictable or frequently evolving. Frequently evolving means the nature of the data changes. Now, another point is query language, structured query language. SQL databases use the structured query language, that is SQL as their query language. SQL is a powerful standardized language for querying and manipulating data in relational databases. On the other hand, in the case of NoSQL databases, they use different query languages depending on the data model. We will discuss about various types of data models in the coming courses. For example, key value databases usually do not use complex query languages for data retrieval. These databases retrieve and store data quickly using keys. Another example is each document database may have its own query language. MongoDB, being a specific document database, uses its own query language MQL. Now the fourth point is scalability. SQL databases are typically designed for vertical scaling, that is scaling up, which means that the performance of the database can be improved by increasing server resources like CPU, memory, and storage or other resources. You have seen the trees which grow in this way, that is upward. So this is known as vertical scaling. Suppose there is a house, there is a vacant plot, and you have built a room on it which can accommodate say 2 persons. With the passage of time, the size of the family increases and you have two options before you. Either you take or build a separate house, or you can construct another room on it. On the same plot, you can construct another room. It is in the same way that in the case of SQL, there is vertical scaling. That is, we do not add more servers to meet up the expectations. That is, if the organization feels that the volume of data is increasing, it needs to make use of more servers or upgrade the present server. In this case of SQL, vertical scaling is used. That is, this server is upgraded, its memory, its storage capacity, or CPU is increased, and though scaling out, that is adding more resources, can be possible in the case of SQL, but adding more servers is complex and expensive for SQL databases. So in the case of SQL, it is preferred that scaling, a vertical scaling, that is scaling up technique is used. That is, we increase CPU, RAM, storage and other resources so that we can handle the increasing data volume. Whereas in the case of NoSQL databases, they are designed for horizontal scalability. Horizontal means in this way, that is increasing the number of servers so that the increase in that data may be properly handled, which means that the performance of the database can be improved by adding more nodes or servers to the database. NoSQL databases can continue to function even if one or more nodes fail. That is, suppose if there are 4 servers working, even if one server fails, other servers will continue to function, and overall the functioning of the organization will not be affected. You can scale your NoSQL databases up or down as needed. That is, if the organization feels that the volume of data which it has to deal with has decreased. Suppose the organization's business is not growing at a very fast speed, and the organization thinks that it need not to have the facility of as much servers as it is utilizing as on day. So it may decide to reduce the number of servers it is using. Adding more servers can accommodate increased traffic or data growth, and you can remove nodes when demand decreases. That is, when the demand of the servers in respect of the service you want to provide decreases, that is, your need for data storage decreases, then automatically you can decrease the number of services. This is possible in case of NoSQL databases. Next point is use cases. SQL databases are best suited for structured data. We give the examples of structured data. These are customer records, product inventory, and financial transactions. Whereas in the case of NoSQL databases, they are best suited for semi-structured or unstructured data. And the examples of the same are social media posts, reviews, hashtags, audio video files. Another point is development speed. The development speed of SQL is slower due to schema constraints. What is the meaning of development speed? Development speed means the time and effort required to maintain and build a database system. That is, it takes a lot of time and effort to build a SQL database system in the case of SQL. Whereas in the case of NoSQL, development speed is faster due to schema flexibility and dynamic data. Next point is ACID compliance. We have already discussed in detail about the ACID properties in DBMS, which is atomicity, consistency, isolation. Now, SQL databases are traditionally designed to follow ACID properties strictly. NoSQL databases vary in their degree of adherence to ACID properties. Some NoSQL databases, especially new SQL databases, provide strong ACID guarantees. That is, they strictly follow the ACID properties in DBMS. D stands for durability, while others prioritize performance and scalability over strict ACID compliance. Now, another point is atomicity. SQL databases guarantee that transactions are atomic. That is, the transactions either are fully completed or fully rolled back in case of failure. The failure may be power failure, internet failure, or any other. There are no partial transactions. In the case of NoSQL databases, atomicity depends on the specific NoSQL database. The atomicity of the transactions may be more relaxed. Next point is consistency. SQL databases ensure data consistency, enforcing rules and constraints. We will also discuss in detail how the relational model ensures data integrity through constraints and rules. On the other hand, NoSQL databases, the level of consistency enforcement varies among NoSQL databases. Some NoSQL databases offer strong consistency, while some other NoSQL databases provide eventual consistency, which allows for temporary consistencies that are resolved over time. Next point is isolation. SQL databases provide isolation between concurrent transactions. This means that concurrent transactions do not interfere with each other, and each transaction appears to run in isolation from others. Isolation levels in NoSQL databases can differ. Some databases offer strong isolation, while some other NoSQL databases offer weaker forms of isolation. Next point is durability. SQL databases guarantee the durability of committed transactions. Committed transactions are those transactions which have been saved in the database. Once a transaction is committed, its changes are permanently stored and will survive system failure. Durability guarantees are typically maintained in NoSQL databases. Once data is committed, it is durably stored. However, in certain situations, some NoSQL databases allow users to reduce the level of durability in exchange for improved system performance. Next point is data structure. SQL databases store data in tables which is made up of rows and columns. Each table in a row represents a single record, and each column contains a single piece of data about that record. You have already learned that in the case of a relational model, there are rows, these are the columns, and we may here take the example of employees. In that case, there may be column heading employee name, employee ID, then employee contact number, and much more. These are, this is row and this is the column. This is what is written in this row is known as the record, and what is written in the columns, it is known as a single piece of data about that record. On the other hand, NoSQL databases store data in different ways depending on the data model they use. For example, key value databases store data as pairs of keys and associated values. Document databases store data as documents, and graph databases store data in the form of graph-like structure. Now we will see the examples of SQL databases. The examples of SQL databases are Oracle database, MySQL, Microsoft SQL Server. In the case of NoSQL databases, the examples are MongoDB, Cassandra, Redis, Amazon, DynamoDB. Now we will conclude the difference between SQL and NoSQL databases. The choice between SQL and NoSQL databases depends on the specific requirements of the application, that is data structure, scalability needs, query complexity, or performance goals. Many organizations use both SQL and NoSQL databases together. Why? To handle the different types of data storage and retrieval requirements. For example, an organization might use a SQL databases to store customer data, and the same organization may also use the other database, that is NoSQL database, to store social media data. We may take the example of Amazon. It may use both types of DBMS, SQL to store the customer information or product catalogs, and NoSQL database to store social media data, that is the audio video files, reviews by the customers. If the organizations use both type of databases, then it allows the organizations to get the best of the two worlds. To get the best of the two worlds means to get the benefits of both types of databases. And what are those benefits? The flexibility and scalability of NoSQL databases, and the performance and ACID guarantees of SQL databases. That is, the organization can take the benefits of strengths of both these types of databases if they use both of. Now the topic before us is, how does the relational model handle data integrity and enforce constraints? The relational model is the basis of most modern relational database management systems. Relational model provides mechanisms to handle data integrity and enforce constraints. Here are some key features of the relational model related to data integrity and constraints. We will discuss about the same with the help of these subheadings. First is entity integrity, referential integrity, constraints, and ACID properties. First is entity integrity. The relational model ensures entity integrity through primary keys. The primary key constraint ensures that no two rows in a table can have the same key values. Here in this case, this is the primary key, customer ID. Now the primary key constraint ensures that no two customers out of the whole customers have the same values in the customer ID. That is, if the one customer is having this ID C12345, then in the whole of the table of customers, no other customer should have this customer ID. For example, in the customers table, customer ID is the primary key and it ensures entity integrity. Each customer is uniquely identified by their customer ID and no two customers can have the same customer ID. The same applies to the employees table. That is, no two employees can have the same IDs. Here in the case of customer table, customer is the entity. In the case of employees table, employee is the entity, and so on. Now the next point is referential integrity. It is maintained through foreign keys. A foreign key is a field in one table that refers to the primary key of another table. We have already discussed in detail about the relational model, primary key, foreign key, composite key in detail. You can see the same. Foreign key establishes a relationship between the two tables. We will understand this concept with the help of an example. Suppose you are having two tables. One is customers table, another is orders table. In the orders table, here you will see the customer's ID. It is the foreign key which is having the relation with another table, that is the customers table. Here customer ID is also appearing. Here it is the primary key. Now this customer ID which is appearing in the orders table refers to the customer ID in the customers table. This foreign key has established a relationship between two tables. Now each customer ID in the customers table must refer to a valid customer ID in the customers table, ensuring that referential integrity is maintained. This step ensures that we cannot insert an invalid customer ID. That is, if suppose we want to insert customer ID which starts with A12345, but all our customer IDs are which are stored in the database start with C. So the system will not allow you to feed this customer ID in the orders table. This step ensures that you cannot insert an order record with a non-existent or invalid customer ID, preserving the referential integrity of the database. That is, what is being referred to in this order table, whatever mention has been made about the customer ID, it must refer to some valid customer ID in the customer table. Now the other point is constraints. The relational model supports various types of constraints to enforce data integrity rules. We will now discuss some commonly used constraints. First is unique constraint. Unique constraint ensures that a column or a combination of columns have unique values across the table. Here we take the example of email column and phone number. We can apply unique constraint on these two columns to ensure that no two customers or no two employees have the same email ID or phone number. This safeguard or constraint ensures that specific columns contain only unique values, preventing data duplication. For example, if the person is feeding data on the system and through an oversight he feeds the same email ID in this field also, the system will not allow the same, and in this way database integrity is maintained, that is data is proper. It will ensure, unique constraint will ensure that the data is proper throughout the database. Next point is check constraint. Check constraint defines a condition that must be satisfied for the data in a column or columns. It prevents insertion of values that do not meet the specified conditions. We will now understand the same with the help of an example. Suppose you have orders table with you. Now, this table contains information about customers' orders which are placed by the customer from time to time. You want to ensure that the order status, this column, contains certain predefined values such as pending, processing, shipped or delivered. That is, the customer make the orders and the said orders are fed in the system, and you want that here the order status should have predefined values. That is, we cannot feed ourselves what we want to say. There will, the options will be given such as the order is pending, order is shipped, order is delivered, or under processing. You can use a check constraint to enforce this rule. Any attempt to insert a value in the order status outside of the specified list will result in a constraint violation error. That is, if you try to insert any other data outside these four, pending, processing, shipped or delivered, though you may change what type of values you want to insert at the level of database designing. Here we are taking the example of that we are having only four options which are there in the, which we have designed in the system. So if we try to insert any other value in the order status, the system will not allow us to do the same and it will show constraint violation error, thus maintaining the integrity of the database and ensuring that only valid order statuses are recorded. That is, whatever we have selected at the database design level, only they, as per that the database shows what is the present position of the particular order. Next point is note null constraint. This constraint ensures that a column cannot have a null value. Null value means missing value. That is, it ensures that these types of columns which are given here do not have missing value. That is, it is not possible that we leave any of these values as blank. When registering on a website, we have to provide information such as email, mobile number and password. Whenever you go to website, suppose you want to register yourself on Amazon website, the website will ask you what is your name, what is your email address, what is your mobile number. These are the basic informations, and in that case the website will have a not null constraint on these types of information. That is, you cannot leave your name blank, you cannot skip the email address or mobile number, you must have some password when you want to log in. Web developer normally applies a not null constraint. That is, web developer will see that you surely fill these columns to the fields like name, email address, mobile number, password. That is, must fill the same to ensure that these fields cannot be left empty during the registration process, so that the website may communicate with you at any stage if the need arises. This helps in maintaining data integrity and prevents incomplete user records. It only enforces the presence of data and not its correctness. It is an important point. Suppose while filling the email address, Suppose abc.com is a valid name, just like gmail.com, it is valid. Suppose in case of Gmail, you mention in the record @smail.com. It may or may not be possible that any such email address exists, that is @smail.com. Gmail is valid, but the system will not check whether any service is there in the name of smail.com, whether there is any company which provides this service of email facility. The system will not check the same. Here the constraint is only related with that, with this aspect, that the information should not be left blank. It is quite possible that you may mention your this name as wrong. In the place of Suhail, you write Suhil, Suhil, whereas your complete name is Suhail. The system will not check all this. It is only concerned with the concept that you fill some information here. Next point is default constraint. This constraint specifies a default value for a column if no value is provided during insertion. Suppose a new employee has joined your organization and you are fill the data in respect of the same in your system. Either you fill the same date of joining yourself, or the system will automatically take it as the current date. It is quite possible that a person has joined 3 days ago. You may fill the same, but if you do not fill the same, the default constraint will automatically take the date as the current date. Now read what is written. For example, if a new employee has joined your organization and you do not explicitly specify the date of his joining, then the system will automatically use the current date as the default value as the date of his joining. The default constraint provides flexibility while ensuring that date of joining is available for every employee, even if it is not explicitly provided. That is, this field is available for every employee, that the date of joining must be there in respect of each and every employee. Now the next point is cascade and restrict actions. These cascade and restrict actions define how changes to referenced rows in a table, usually the parent table, affect related rows in another table, usually the child table, through foreign key relationships. It means that suppose there are two tables, one is customer table, another is order table. Customer table, where customer ID is given having primary key, is the parent table, and the customer table where there is foreign key is the child table. And if you make any change in the first table, that is the parent table, customer table, then the effect of the same should be there in the order table, that is the child table. Now we will discuss the same in detail. First is cascade action. Cascade action in a relational database is like a domino effect. You might have seen that if an international bank which is having branches across the globe falls means building, not building falls, if it fails in the international market, that is its shares plunge due to any reason in the share market, then it has a domino effect, that is the whole of the share market in the world collapses on that day. It is the domino effect, that is there is the resultant effect of the same on the whole of the world. In the same way it happens in relational database. It means that when you make a change, for example delete, to a particular piece of data in a table, those changes automatically affect and are applied to the related rows in another table through a predefined relationship. That is, whenever you delete, suppose customer ID in the customer table, then it will have its effect on the orders table. That is the related rows in another table through predefined relationship. That is the system is given instructions or what type of effect should be there if we delete something in the parent table, what type of effect it will have on the child tables. It is already decided in advance at the level of database designing. Now we will understand the same with the help of an example. The authors table, this is the authors table, has a foreign key reference in the books ID. Here it is the foreign key. This is the primary key. Here it is the foreign key. It is having relationship with this author ID in the authors table. When you perform a delete operation in this table, that is, suppose you want to delete this author, J.K. Rowling. The cascade action automatically propagates those changes to the related rows in the child table. How it happens? If you decide to delete the J.K. Rowling from the authors table, the cascade action will automatically delete related rows in the books table, ensuring data consistency. That is, if you want to delete the author's name from the parent table, it will have its effect on the other tables which are related to it. In this case, this author is having a book in its name in the books table, which is this one, Harry Potter and the Chamber of Secrets. Now, if you delete this author, then the cascade action will ensure that this book is also deleted from here. And what will be the resultant action after the cascade action? Author is deleted. In the same way, this book is also deleted, and the new book table will here appear in this way. You can see that here the number of authors were 3. First was deleted, and its book which is here at number 1 is also deleted, and here only 2 authors are there and only their relevant books are appearing. Now the another is restrict action. When you perform an update or delete operation on a row in a parent table, we take the first example that here we want to delete the name of J.K. Rowling. The restrict action prevents the operation if there are related rows in the child table. You will not be able to delete this row if there is a related book in its name in the books table. Here we take the example that we are deleting the name of J.K. Rowling from author's ID. But there are books which are available in the books table. The restrict action will block the deletion of J.K. Rowling from the author's table until all related books are either deleted or association is deleted. That is, either the relationship between this author and the books table will have to be removed. Relationship should not be exist in the system, or firstly we will have to remove the books from the books table. Only after that the system will allow the deletion of the author's name. Firstly we will have to delete the relationship existing between the books and the author, or we will have to delete the books which are existing in the name of the particular author which we want to delete. Here it is important to note that restrict action takes the first place and the cascade action takes the second place. That is, if restrict action has been allowed in the system, then restrict action will take precedence over the cascade action. When a restrict action is in place for the foreign key relationship between the authors and books table, you cannot perform a cascade action to automatically delete related books when you attempt to delete an author. In the cascade action, we had learnt that if we delete the author ID, the books which are to his credit in the books table will automatically stand deleted. But if the restrict action is in place, we cannot do the same. The system will allow the same. The restrict action takes precedence and restricts the deletion of author to maintain data integrity. You would need to first delete the associated books manually. That is, here you will have to delete this book manually, or you would need to remove the association between the author and their books. Only after that the system will allow you to delete the name of the author. If there is an author which is existing in the authors table, but it is not having any book to his credit in the books table, you can delete it altogether. There will be no problem if even if there is a restrict action in place, because there is no book to his credit, and so the system will allow you to delete his name from the author ID, because there will be no book in the books table which will be having the author ID which is not existing in the authors table. These cascade and strict actions help maintain the referential integrity of the database by automatically updating related records or preventing actions that would leave the database in the inconsistent state. That it means that if the system allows you that you can read the name of the author, then what will happen? Author ID will appear in the books table, but the system will not show who is the author, because the author ID has been deleted and system allows the same, but its related books are still existing in the books table. And when you try to find out from the system itself who is the author of the particular book whose author ID is appearing, there will be no author available in the record of the database. So it will result in some form of inconsistent state. They are important tools for ensuring data accuracy and reliability in real world database systems. Now we will discuss about another properties which are known as acid properties, which are very important in DBMS. We have discussed about the same in detail in our earlier courses. The relational model also relies on acid properties to ensure data integrity. Here A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. These properties, that is these four properties, ensure that the database transactions are processed reliably and maintain data integrity. Atomicity means that a transaction is either all completed or not completed at all. This prevents data from being partially updated or deleted. Next point is consistency. Consistency ensures that the database transitions from one valid state to another. Isolation means that concurrent transactions do not interfere with each other. Durability means that once a transaction is committed, its changes are permanent. This means that the data cannot be lost or corrupted even if there is a system failure. In the relational model, and relational database management system, data integrity is indeed maintained through the use of constraints and integrity rules. If you travel on a road in your car, you might have seen traffic lights or various types of traffic signs, signals, signs are there, traffic signs are there. For what purpose they are? These types of traffic signals or other types of signs which appear in to us in on the roads, they are there to ensure that there are no accidents and the general public is in a position to safely commute from one place to another. So in the same way, these types of constraints and integrity rules in the relational model ensure data integrity. These rules and guidelines are specified when designing the structure of the database, typically in the database schema. Whenever data is added, updated, or deleted in the database, the RDBMS checks these rules to ensure that they are not violated. Constraints and integrity rules act as safeguards to prevent inconsistencies, inaccuracies, or rule violations. It means that whenever you add something in the relational table, the system will automatically check whether it is as per the rules which have been defined at the level of the database designing, that is already discussed, whether it the customer ID should start with A, B or C, whether the same type of customer email address is already existing or whether the same customer ID is already appearing, whether this customer ID is existing in the database. So all these types of constraints and integrity rules ensure the data integrity in the relational model. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.